So we have done with your all the IBGP concept, like loop prevention mechanism of the eBGP, how we can prevent the loop in the eBGP. We have seen the AS path loop prevention mechanism in the eBGP, and after that we have also seen that the IBGP loop prevention mechanism, by default the split horizon rule is enabled, right? And there is no command to disable the split horizon rule. So you have a three solution: either you can make a full mesh, route reflector, or go for the configuration, right? So full mesh is not a recommendation because it requires the huge amount of TCP session if you have multiple routers, right? And you have alternative solution like a route reflector, or we have a configuration. So route reflector and configuration both are the alternative solution of the full mesh, but the both route reflector and configuration as defined in the different RFC. Okay, so according to your requirement you can implement your route reflector or configuration as well as, right? Because if you're going to use the policy, you go for the configuration. If you don't have much policy, you can go for the route reflector itself. In the route reflector we have two types of attributes. We have seen one, we have a originator ID, and another we have a cluster ID. Originator ID is a 32-bit number that is going to prevent the loop within the cluster, and cluster ID is also 32-bit number that is used to prevent the loop between the cluster. All good. Now, okay, so we have a 1.0 subnet over there, 1.0, 2.0 subnet, 3.0, sorry, 4.0 and 3.0. And all these guys, my RR client, can you see that? RR client over there, RR client, RR client. I want to form a neighborship, right? I want to form a neighborship. Tell me, if I want to provide the communication, forget the communication right now. I just want to form the neighborship between this guy to this guy, this guy to this guy, this guy to this guy, and this guy to this guy. How many commands I need to put router number one? If you just have a look over there, on a router number one, if I'm going to align the configuration, right? We have to put the configuration like this on router number one. And make the 10 is fine, and I'll go for the tally. I put the router BGP number one because all we are going to use the same base number, and someone mic is on, can you disable it? Okay, then I need to put the neighbor command. I need to form the neighborship with the 5.5.5.5, right? And I have a remote AS number one, neighbor 5.5.5.5.5, update source loop back one, or neighbor 5.5.5.5.5. If I'm going to apply the password, I can use the password keyword as a Cisco 123. This command I need to put on every router. On a R2 as well as same configuration I need to put, right? Copy. On a R3 you need to put the same configuration. On a R4 I need to put the same configuration. So every router we need to put the same configuration, right? That's not a big deal. We can do that, right? Let's go on a router number one. Let's start this configuration, right? Four and five. So mic is on. Hey guys, just try to understand about this. This topic is very simple, but in this topic you need to understand the behavior of the router, right? We are just going to reduce the resources of the router in this topic, right? So I need to put the same configuration on the router number one. First of all, I need to show you the whatever the pre-configuration we have, and always it's recommendation to use the check the pre-configuration, right, in exam or any in the production network. So we have a 15.1 and we have one loop back. Let's check the show IP protocol summary. Do we have any protocol is enabled? Okay, we have enabled with the EHGRP. And let's see which interface are enabled in the EHGRP. So hope I'm going to advertise this route 15.0 and this 1.0, so that because in IBGP, as we know that we need to have a reachability, we must need to have a reachability to form a neighborship, right? R1 is good, right? On a R2, if you see, show IP interface brief, exclude unassign, show run section EHGRP, all we got to go, right? So we are enable all these things, show history, I can do that, and put the same configuration on R3. All good on R3 also perfect, right? 35 or 3, and we have one loop back and in EHRP is enabled. Router number 4, Please 1 minute. Yeah, Farhan, I called you, right? Oh no, evening. You're not there. Okay, I'll do an can we talk after the 1 hour? I have session right now. Yeah, perfect. All good, right? So on a router number 4 also we have same IP addressing configure 45.4.4.4 and we are going to enable the HGRP, right? And if you just go on a router number 5 right now, so IP interface brief, same configuration. So all we have IP addressing, but HGRP is not enabled. So let's do one thing. Let's enable the HGRP on the router number 5. All done, right? What is my goal? My goal is there is a one route behind the R1 that's a we can say that 11.0.0.0 and 20.0.0.0 slash this two route need to advertise on every router via the BGP. So this two route should be advertised, or we can say that this route should be present on every router via the BGP, not through the EHGRP. This route. So what happened? First of all, I need to form the neighborship. So this is the command, okay, that I written over there. So I need to copy this command on every router, router number 1, 2, 3, and 4. All done. Router number 2. Every router is going to form the neighborship with the server, right? Because I'm going to make a router reflector client and server, right? So every router is going to make a neighborship with the server. So R5 is my behave like a server. Now, try to understand one thing. I did the configuration on the client side, right? Whatever the configuration on the server side. This is my client configuration. You can see that R1, R2, R3, R4 is my client, right? This is my client configuration. Whatever the configuration on the server side now. On a server side, I need to put the same configuration. Let's do on our server. Let's open a new notepad. And I'm going to do the configuration on the server side. On a server, the router number 5, right? I said router BGP number 1, right? Of course, I need to define the BGP router ID. If you want to define, you can define the manually. That's a 32-bit number. I need to spawn the neighborship with the which person 10101. Remote age first. I need to define this guy. Neighbor 10101. Update source loop back number 1. Neighborship. I'm going to form the 10101. I'm going to say the password will be Cisco 123. Right? Anything else? I need to say a neighbor 10101 and route reflector client, right? Because I need to define, hey, you are my client, right? Same configuration I need to for the which person now? R2, R3, R4. I just need to change the IP addressing, right? 2.2.2.2.2. Copy. With the 3.3.3.3.3 now. Copy. This guy and this person now. And then we have a 4.4.4.4.4. Come on. Now, this configuration I need to put on the router of 5. Let's take a one example. I want to apply some policy. Take example, I want to apply some policy. For example, I want to do some filtering, right? So in that case, what happened? I want to do the form some filtering, or either I want to do the some kind of path manipulation, anything. I need to apply some route map over there. So how do I apply the route map? If any new policy is coming, right? Take example, if any new policy is coming on a router number 5, right? So how do I do that in this case? You need to go on the router number 1 and say neighbor 101, and I say the route map Cisco, whatever the route map we have. This command you need to put on every single neighbor. With this guy now, and with this guy now. If any new policy is coming, after some time again new policy is coming, again you need to put the command. After that, sometime again new policy is coming, again you need to define the every command line on a particular neighbor. Can you imagine? Just imagine that, right? Just imagine if you have a 100 plus neighbor. Is it possible that you are going to do the configuration for the 100 plus and you are doing the manual configuration, guys? Just take example. What happened if this is the case sensitive, right? This person is a case sensitive. Maybe I'm just going to put the wrong name over there. The policy will be not applied. Right now, guys, try to understand what is the common thing is happening over there. Right now, what is the common thing is happening in this all command line? If you see the common thing on a R5 router, right? The common thing is have this person remote edge number, right? Update source loopback, password Cisco 123, and route reflector client. These are my common things on every single router. Can you see for every single neighbor? These are the common things. Can I do like this? I'm just going to put the all the common things into the one single box. I see that, hey, okay, remote AS will be one, update source loopback will be one. I'm going to say the password will be Cisco 123, and I'm going to say the route reflector client will be. I'm just going to make a one box over there, right? Or we can say that a group. A group. I'm going to make group is what? A collection of something, right? So this is the collection of update source, loopback, remote AS number, password Cisco 123, and route reflector client. I'm just making a one group over there. And I'm going to define this group name, maybe anything. I can go for the CCI, or instead of applying this command configuration on the particular neighbor, can I apply this group name? I say that, okay, I want to form the neighborship the 101. I'm going to use this group CCI. 2.2.2.2.2. I'm going to use the CCI group. 3.3.3.3.3 CCI group. 4.4.4.4 CCI group. So whatever the information are posted in the CCI group, all in configuration will be pushed to the this particular neighbor. 1, 2, 3, and 4. So can you imagine how much amount of line of configuration, how amount of line of configuration you can reduce by just making a group? After creating this group, right, I'm just going to apply this group to the particular peer. Peer is what? In a BGP term, the peer is known as a neighbor. I'm just going to create a one group, and that group has a similar properties, right? That's the meaning of group. Group is what? A common properties they have, and that is going to achieve the same goal. So the goal is what? I'm just going to form the neighborship, and group name is CCI over there, and I'm going to apply this group to the particular peer. This mechanism is known as a peer group. This mechanism is known as a peer group. So by using the peer group, what happened? We are just going to reduce the huge amount of configuration. By using the peer group, what happened? We can reduce the misconfiguration. And take example, if the new policy is coming, right? Take example, if the new policy is coming, I'm not going to apply the policy to the particular neighbor. I'm just going to put the policy over there. Route map, Cisco, inbound. That's it. So once I'm going to put this policy into the particular box, CCI, what happened? This policy automatically enabled for the R1, R2, R3, and R4. You don't need to do anything. So this benefit, if the new policy is coming, if the new policy is coming, I just need to apply to peer group. instead of the particular neighbor. Instead of the particular neighbor, I just need to apply to the peer group, right? That's it. So peer group, the main agenda, the main goal of the peer group is just going to reduce the lines of configuration. It is going to reduce the amount of configuration, right? So this guy, let me write on this thing in the paint. Then you will just scale it to all of you. By making a peer group, the benefit we are getting over there, reduce configuration. Second thing, if any new policy is coming in future, instead of applying, instead of applying to particular neighbor, we just need to apply to peer group. Another benefit we have, that's the most important benefit, we can reduce the CPU cycle. Because if you have a huge amount of configuration, right? If you have a huge amount of configuration that require a more CPU cycle, right? I'm going to reduce the CPU cycle, reduce the wastage of memory, right? And then improve the router performance. This benefit you are getting by using the peer group. So group means what? Of common properties. That's the meaning of a group. And this group will be applied. So I'm just going to make a one group over there. So this is the group name, and I'm going to make a, this group name is a CCI. Anything, it's totally up to you guys. I'm going to make this guy's group name CCI. Make sure that this name is a case sensitive, right? This name is a case sensitive, and in this group, I'm just going to put the whatever the configuration I want. I want to do that. Remote edge number will be 1. Update source loopback will be 1. Password will be Cisco 123, and route reflector client. So instead of applying individual configuration to the individual neighbor, I'm just going to apply this group name to the particular peer CC. This mechanism is known as a peer group, and you can do the peer group for IBGP as well as and for EBGP as well as. So you can achieve this peer group configuration for the IBGP and EBGP as well. So now if you just compare the configuration now, if you just have a look right now after making a peer group, so this is my configuration between the peer group. I'm going to make a peer group configuration now. What I'm going to do, I'm just going to router number 5 and have a look. Router BGP number 5, sorry 1. As a neighbor, right? In a neighbor, I'm just going to say the IBGP. That's the name of the peer group. I can go to CCI peer group. This is the name of the peer group that I'm going to create over there. And in this peer group, I'm just going to apply. How? I say that, okay, put the remote edge neighbor CCI. This is the name. CCI is the name, right? CCI is the name of the peer group, right? As the remote edge will be 1. neighbor CCI, the password will be Cisco123, neighbor CCI, the update source loopback will be 1, and neighbor CCI, I say the route reflector client. And now I'm going to apply this neighbor peer group to the particular neighbor 101 peer group CCI neighbor 2.2.2.2.2.2 peer group CCI neighbor 3.3.3.3.3 peer group CCI and neighbor 4.4.4.4.4 peer group CCI. Now can we have a look now? How much line of configuration I can reduce? So if you just have a 4 neighbor, right? This configuration, the peer group is only required when you have a huge amount of neighborship. For example, 100 plus, 50 plus neighborship. I cannot make like this right now. Okay. But if you just have an example of the 4 router right now, 4 neighborship, R1, R2, R3, and R4, right? How many things is happening? If you see 4 lines, 4 lines, 4 lines, and 4 lines. Total is a 16 line of configuration. If you do without peer group, without peer group, you have to do the 16 line of configuration. With peer group, you need to do the 5 plus 4, 9 line. So 9 to the 16. Can you see the difference is happening in just a 4 new? It's a 9. Yeah. See the difference, how much amount of configuration you are going to reduce. Hey man, router is not like that only going to form the BGP neighborship. Router has a different work as well as they have a work of the IPsec, MPLS, VPN, NAT, PAT. They have an NTP, multiple things the router can do. Router saying that, hey, I have multiple tasks. I'm not going to interested to run the BGP only. Why are you putting the lots of configuration? Can you imagine just if you have a 50 plus router, your complete running config will be stored with the peer group. Sorry, your complete running config is stored with the neighborship only. Neighborship. So what I'm going to do, I'm just going to put this configuration on the router number 5 now, instead of doing this configuration. So if you see it on a router number 5, all done. Now they'll form the neighborship with every person. Just wait for some time. Password I'm saying, yep, 3. Then you're getting the 2. Also we get the 3, 4, and 1 as well as. So BGP is a little bit slow routing protocol. You just need to have patience, right? 1 and 4. So now if you see, so IP BGP neighborship summary, I have all neighborship over there, right? And let's do one thing on a router number 1. I'm going to create this 2 loop back. Okay, just I want to show you this thing that I want to send this information through the BGP, right? Interface loopback number 20. That should be a 20.20.20.20 slash 8. I'm going to advertise this router BGP number 1 network 11.0.0.0 network 20.0.0.0. R1 will send the update packet to the R2, sorry, R5, show IP BGP. So if you see, okay, 1 minute, I mistake. 1 minute. Okay. Wait for some time. Clear IP BGP is stick hard. It will form the neighborship. So neighborship I have. So it is going to make this guy as a best out as well. Don't worry. So I get the all information right from R1 is going to say the all information to R5, and R5 will reflect this information because R5 is a server. So R1 will say this information to R5, R5 will say, reflect this information to all the client information, right? And I just did this configuration by using the peer group. So this amount of configuration that you are reducing, guys, by making a peer group, this amount, you compare this one to this one. This is the 9 line of configuration, and this is a 16 line of configuration. 16 is there. If you have a big network, right, you can implement the peer group. So you can also verify the peer group configuration. How? You just need to use the show IP BGP peer group. Okay, you can see they will show you the information, right? I'm going to use the peer group, that's the name is CCI over there, right? And remote AH number 1, that I'm going to use the AH number 1. I'm going to use the BGP version 4, that you cannot change the version. If you remember that I showed you that you cannot change the version, there is no command, right? The command is there. If you see, the command is there, right? Neighbor 101 as the version, but in the command line what happened, there's no option for the 123, right? It's totally opposite, because 123 is version is a classical, right? So now if you see this, I'm going to apply for the address filing unicast, and I have a neighborship with the CCI, that is the peer group is the internal. It's just going to tell you it's an internal BGP. If you have external, it will show the external. I have a members right now 1, 2, 3, 4. And on this peer group, I have also applicable the route reflector client. So through this peer group, you can get all this information, guys. At the same time, you can do the peer group, right? You can do the, for example, now take example. I want to do some policy. How would I do that? I don't need to apply for the particular neighbor, right? I don't need to go for the 1, 2, 3, 4. I just need to go on what is the peer group name? CCI, see the route map, take a route map, anything A. Okay, in one. Done, right? So now if you see store on section BGP, what I did over there, in a particular on a particular peer group, right? CCI, I just applied my policy, right? The mic is on. I just apply. If any new policy is coming, I don't need to go for the particular neighbor, right? That's my this point is saying that if any policy is coming in future, right, instead of applying to the particular neighbor, we just need to apply to the peer group. That's a awesome feature, right? This is the beauty of peer group. All good. Now the same thing you can achieve through the EVGP as well. As for example, if you want to do for the EVGP, I can do that as well. As how to do that? Let's do one thing. I'll I'll make a new project, right? Because a long time before I did the peer group EVGP practical. I'll make this class to close it. I'll show you in the two case right now. I'll go for the three daughters is enough, right? So I'll make this guy like this, R1, R2, and R3, right? And they have a different AH number. So if you're going to use the peer group for the like EVGP, you can also do that. So let's take example and let me change the icon of this guy in symbol. Right? So we have three daughters, daughter number 1, daughter number 2, and daughter number 3. They all belongs to the different ACE number. So we can write on this guy's IP address will be 12.1. This guy will be 12.2. And every daughter has a loopback. So I'm forming a neighborship with the loopback, right? Always one thing remember, guys, BGP works on the TCP. We always need a reliability, right? So we have a 2.2.2.2.2. That's my loopback number R2. We have a 3.3.3.3. That's loopback number R3. And we have a loopback number 1, that's a 1.1.1.1, right? And all these guys belong to the different autonomous system numbers. So I can say that this person is belong to the age number 2. So lower one layer, right? I'm going to make this guy's a style and change this color icon of this guy fill color. We'll go for the yellow one, and I'll make this guy's age number 2. So this guys belong to the age number 2, right? I'm going to make a peer group session, okay? And this guy at the same time duplicate. I'm going to make a different peer group of this guy. Sorry, not different peer group. I'm going to use a different age number of this guy. So this guy belongs to the age number 3. Make the blue. It's fine, right? So this guys belong to the age number 3. At the same time, we have a different AH number, this guy. So we have a one loop back over 101. So this loop back should be like a, I'm going to form the neighborhood with the loop back. Okay. So style and change this color again. The green. Oh, good, right? So different AH number. AH number, this guy should be AH number 1. So what is the basic thing that we need to do, guys, right now? I just need to take a console access, right? And after that, I just need to provide the IP addressing and EHGRP routing protocol to just make a utilities, right? To loop back to loop back. And then then we'll go for the pure configuration, right? So router number 1, they have IP addressing will be interface 0/0, IP address will be 12.1/24/24, no shutdown. Interface 0/1, IP address will be 13.1/24, not 13, it should be 23.2. Oh wow, it has to be 1 minute. It should not be there. It should not. It should be 13.1. Okay, and this should be also 13.3. This should be 13.3. Dot, all done. Interface loopback number 1 that has a 101, and I'm going to form the neighborship with the loopback. So let's advertise all the route. All done. Router number 2, interface 0/0, IP address will be 2.2. Interface R3, that's ACE number 3, right? So 3 different companies are there. We can say that, right? The basic thing that I did, just make a utility of the loopback so that we can form the neighborship, right? What is the next thing I need to do on a router number 1? On a router number 1, right now, if you see, what is the common thing? So let's go on a router number 1. Let's open the notepad first of all. On a router number 1, what is the common thing? I need to use the router BGP number 1. That's my ACE number, right? I'm going to form the neighborship with the loopback to loopback, right? The common things will be have in this case neighbor ABGP. This is the name of the peer group, right? This one is the name of peer group. Okay, that's the ABGP as the upgrade source. This is the common thing, right? Loopback number 1, neighbor ABGP. I can see the password will be Cisco. The common thing will be neighbor ABGP multi-hop, right? No, ABGP, yeah, multi-hop. Anything else? No. I need to apply this guy neighbor 2.2.2.2.2, right? I first need to say that remote AH number, because remote AH is not a common, because this guy has a remote AH number 2 and this guy has a remote AH 3, right? So I'm not going to put the remote AH number. Then same thing with the 3.3.3.3.3, 2. Okay, it should be 3, right? With the same thing with the R2 now. On R2, what happened? R2 is only going to form the neighbor relationship. R2 is only going to form the neighbor relationship R1, right? So no need to do the any configuration. I just need to put the normal configuration. Router BGP number 2, neighbor with the 101, multi of 2, neighbor R3, right? Just need to change this guy. That's it. So let's copy this configuration router number 2, router number 3, and router number 1. Only the difference is happening eBGP and IBGP peer group. In IBGP, we are including the ACE number, right? Okay, what happened? Sorry. It's another version. One minute, guys. Sorry. The remote ASP group first, and then why three guys specifically? Hmm. What, I didn't get it. What I'm trying to say, I didn't get you. Confusion is correct, right? Never image you have to look back, never image you pass also, never image the multi-hop. This command is correct, right? Never image you have to specify the remote AS or peer group command first. Right, I already specified the remote. Okay, just 1 minute. Okay. I think it was then maybe up down mistake will happen. That's all. The only difference is happening if you just compare with this one. I'll show you the IBGP, not this one, and this is the IBGP configuration, right? Not this one. Yeah, this one. So if you just have a look, only the difference is happening over there. I'm putting the in this is the IBGP, right? And this is the EBGP peer group. In IBGP, what happened? We are including the remote AS number, right? But in EBGP, we cannot include, right? We cannot include the AS number because AS number is different, right? R1 is forming the different AS number 2 and 3 as well as. So we cannot include the AS number in a peer group. So the common things is only that updates to loopback passwords is for EBGP monitor. So the peer group, the name as a group means what? A group means a common properties, right? That's the meaning of group. So only the common properties you can put in the group. So whatever the common properties we have, we just have this one, and that we are including, right? So now if you see, show IP BGP, all have summarize, sorry, neighborship, and show IP BGP peer group. Now this peer group will seen as a external. So previously, if you remember that, we had a internal, now we have external. And we have two neighbors in the peer group 2.2.2.2 and 3.3.3.3, and all this peer group is secured by the password. All good? Any questions, anyone, guys, in the peer group? So by using the peer group, you can achieve this amount of benefit. No, Now, hey guys, till this point, whatever things we have seen, whatever the configuration that we did, doesn't matter. We did the configuration for the route reflector, IBGP, neighborship with the loopback directly connected. Everything we did the neighborship with the static neighborship. We put the command neighbor, right? Right now, what happened? We are putting the command neighbor. Neighbor means what? We are doing the static neighborship. Or static neighborship is good, right? Static neighborship is good. But do you know the problem? The problem is very simple. If you just have a look right now, try to understand this this route reflector server, right? This is the route reflector server is positioning which location in the data center, right? Okay, this route reflector server is positioned in data center location. Now try to understand. Right now they don't have a client. This client is not there. This client is also not there. Okay, so we only have a two clients, client one and client two, some different location, right? Then we are trying because BGP has the ability we can form an indirect neighborship, right? They have ability. So try to understand if R1 is going to form the neighborship, what happened? Right now we are finding a problem with the static neighborship. Right now we are just finding the problem with the static neighborship. R5 router, that's my route reflector server, is present in the data center network. All right. These are my branch location. These are my branch location. So what happened? First of all, this network engineer has to go on this router, on a router number one. On a router number one, this guy has to define this configuration, right? Hey, I'm going to form the neighborship with the, not this one. Yeah, this one. Okay. No, this one. Yeah. So now router number one, this network engineer going to do, and this network engineer going to define this command, right? Again, this router number two, sorry, router number one is going to do this net, sorry, not this network engineer has to move this location from data center. And now on a data center, it is going to define the neighborship, static neighborship with the particular neighbor, right? After defining the particular neighborship on the router number five, they can form the neighborship. After that, this guy had changed the location from this location side branch two, and on a branch two number, they are again going to put this configuration, right? Static neighborship. And again, this branch, this person has to come in the data center network, or they can take a telnet access as well. That's not a big deal. And they have to again configure the client. So every time what happens, you're doing the static membership, there's no issue. But take example, after some time, what happened if the new branch is coming in your network? And this branch, guys, is want to make a neighborship with the data center. How do I do that? Again, you need to go in the router number four, take a telnet access, or make a console and make a neighborship with this person. Again, you have to involve the data center network. Again, after some time, in the new branch is coming out there, what happened? You have to go on the router number three, make a static neighborship with this guy, and you have to come in the data center network. Again, you have to define the neighborship with the particular this guy. So at the end of the day, what happened? My conclusion point is very simple. At the end of the day, what happened? If the branch is coming, you have to define the configuration of the branch, right? That's mandatory. Why you are involving the server? Why you are involving the server? Do I need to involve the server over there to every time configuration static neighborship? And don't you think the static neighborship is going to make a chaos on the router number five as well as every time you are coming on the router number five, and maybe sometimes by making some mistake over there, if the router number five some issue, get the some issue, right? Then whole network will be down because this is my server, right? This router number 5 is very critical because this is the server. Everyone is trying to form the neighborship with this guy, and this guy is a route reflector server. It is going to reflect the route. It is going to reflect the route. It's very critical, right? And on this critical server, what happened every time you're taking a telnet access or as such, or either take a console access, right? To just make a neighborship. If the new branch is coming, you have to define the neighborship. Can you imagine if you have a 300 neighborship? Every time you have to go in the router number 5 and form the neighborship. Every single time. Not possible in this case. So what happened? I can do the dynamic neighborship configuration on the R5. BGP allow you to form a dynamic neighborship. BGP allow you to form a dynamic neighborship. On a router number 5, I'm going to enable the dynamic neighborship, but on a router number 1, they still form the static neighborship. It's still static, still static. So what happened? Because why I'm going to do the static neighborship on the client side? Because every client is going to form the neighborship with the server. Copy. Router number 1. Let's see the what are the pre-configuration we have. 2, 4, 3. If you go back to the router number 1, first of all, the pre-configuration show IP interface brief, show IP protocol summary. EHRP is not there. Let's enable the EHRP. Router number 2. EHRP is not there. Let's enable the EHRP because we need a maturity, right? 3, 35.3 and 3.3.3 also IP protocol summary. EHRP is not there. Let's enable the EHRP. And router number 4. All done. Let's enable the EHRP. Router number 5. Let's verify the show IP interface brief configuration, right? All good, right? All we have a good configuration router number 5 as well as 15.50/0, 45.5 on a 1/0, 1/125.5 and 2/0. All good. What I'm going to do, the basic configuration on the router number 1, copy on every router. Every router is going to try to form the neighborship with the server. Done. Done. R3. Done. R2. What R5 I'm going to do? On an R5 router, first of all, the basic, I need to create the peer group. Common thing is there, right? IBGP is there. Go for the peer group. As a neighbor, IBGP peer group. This is the IBGP is the name of the peer group, neighbor IBGP. I'm going to put the remote edge number 1. I'm going to put the update source loopback number will be 1. I'm going to put the password will be Cisco 123. I'm going to put the next thing I'm going to put what I'm going to put the router client, right? And then I'm going to inform the router number 5. Hey dude, do one thing. Whenever any person is sending a request to you, hey, let's form the neighborship, doesn't matter what source is there, because this guy is sending the different source, this guy is sending the different source, this guy is sending the different source, and this guy is sending the different source. Doesn't matter what source they are sending, right? You have to listen. I'm informing the router number 5. You have to listen. Every person. How do I max the every person? And whenever you are going to listen for the every person, what policy I need to match to form the neighborship? This peer group name, right? Done. Did I define any kind of neighbor statement over there? No, this is the dynamic neighborship. And how do I identify this is a dynamic neighborship? By saying this star value. In a normal, if you go for the router number one, do we have any star on a router number one? No, we don't have a star. But on a router number five, they are forming a dynamic neighborship. R1 is forming the static neighborship, right? R1 is static neighborship, but R5 is forming the dynamic neighborship. Star is there. So if you just have a look over there, show IP BGP neighbor, not neighbor, somebody, you go for the somebody. What happened? You see, our five neighborship and all this five neighborship has a star value, right? This star is only comes in the picture whenever you're going to form the dynamic neighborship. Star is going to represent dynamic created based on which listen group. You can also put the any num ID, network ID. It's totally up to you. I can put the 192.161.0. I can put the 1.0.2.0, anything, right? Just for the security. And how many dynamic neighborship I can create over there? I can create maximum 100. So maximum 100, I have a 4 right now. And which subnet I'm going to use right now? 1. You can use the multiple subnet. It's not like that. For example, router BGP number 1. I can say BGP listen 1 minute. BGP listen range. This was the range that I have got. The group that I have created IBGP, right? I can use the different range as well as I can say that, okay, your range is now, you can range is now, take another range as well as it's totally, for example, I have a class B. So all the loopback that belong to the class B, I can make a class B as well as, so IP BGP somebody. 3 subnet range I'm going to use over there. This guy, this guy, and this guy. So it's totally depend on the requirement. If you have a different one, you can use the 0.0.0. But if you have a same subnet from class A, class B, you can use this guy as well as right class E according to your different requirement. Even you have a ability right now. What happened? If you see one thing, router BGP number 1, I see the BGP listen range, and I have a keyword limit. If you see how many neighborship I can support over there, maximum I can support the 5,000, but default is what? This guy. Default is 100 is max. I can support the 5,000. I can say that, hey, range will repeat now to show IPVGP summary now. What happened? What is the limit over there? Maximum 2. Let's do one thing. Clear IPVGP hard. What happened? See this message. Maximum MAX, maximum dynamic DYN neighborship. Cannot create a new neighbor with the owner because the maximum limit that I did over there just 2. So you have an ability to control this thing as well as guys. It's totally up to you. I'm telling you, right? Many things in the BGP, it's totally up to your requirement, right? Once you have experience of the 5 to 10 years experience, right? Once you have a CCI number, once you go for the design label things, right? Once you become the architect, you need to analyze this small things over there. Okay, do I need to make this guy? Do I need to use the which statement? If you see right now, let me do one thing. Let's make a default one. I'm going to remove this guy. Okay, so they'll form the new ship. If you see do show run BGP. So can you see that I have used the 3 subnets over there? I can use it, right? But once you become architect level, you need to find out, okay, how many subnets I have. Do I need to see this is the wrong, right? If I'm going to talk about according to the perspective of the design, but this is wrong because in this one, what happened? Anyone can try to form the neighborship if they are able to crack the password. If they are able to crack the password, they can form the neighborship. Okay, so better to do this one, whatever the range you are going to use in the summit, right? So this start is just going to form the dynamic neighborship, and dynamic neighborship. I'll tell you the best example of dynamic neighborship where you're going to form, right, in a DMVPN. And to do the dynamic neighborship, guys, always you have to remember to do the dynamic neighborship, you need to first create the peer group. Without peer group, you cannot achieve the dynamic neighborship. Never ever. Without peer group, you cannot achieve the dynamic neighborship. You must need to have a peer group. And the best example you can do the dynamic neighborship in the DMVPN in the spoke to hub. Because if you remember that, those who attend the advanced classes in the DMVPN, we went through that, like a hub has a dynamic, right? So every spoke is trying to form the neighborship with the hub. Every spoke is trying to form the neighborship with the hub, right? So on a hub, what happened? I can make a dynamic neighborship on a client side. On a spoke side, we can form a static neighborship. So on a hub, I'm going to use this command BGP listen range. So we are making a pure. Otherwise, what happened if you're not going to form the dynamic neighborship on a hub side? What happened? This DMVP and this D needs to work dynamically, right? This dynamic will not work over there. Still, you're doing you did all the HRP configuration, all the MGRE configuration as a dynamic way, but the BGP is what is still static. So the best solution of the DM as best example of the dynamic neighborship in a DMVP sector. Any questions, anyone? Okay, I'll show you one more thing. Okay, the best thing I want to show you right now. R6 and R7. I'm going to show you the authentication things over there. Okay, that's a little bit important, not so important. You just need to have idea how this. See, authentication, to authenticate the person, right? But in BGP, in BGP, what happened? The password, the MD5, right? The MD5 password that is will be exchanged in the encrypted format, but is not going to exchange in the BGP packets. It's going to exchange the TCP packets. So if you let's form a new which I don't know. Two, right? Oh, that's what's this two. Now good. When I forget the one thing in which option flag, I think so. Yes, in this one TCP. I think so. Option is a 19 option maybe there. 19 or 17 maybe. Okay. So it is TCP sync packet is there. If you see the sync flag is there, in the sync flag, what happened? I'm going to send the TCP MD5 signature value. The TCP option is I think 17 or 19. 19, yeah. Okay, 19. So the MD5 signature option I'm going to do, and this is the MD5 digest value. So in a TCP sync packet, we are going to exchange the MD5 value, not the BGP packet. If somebody asks you in the question in the interview, hey, in which packet we are exchanging the password information? We are exchanging the password information in the TCP sync packet, not the BGP. If you see the BGP packet, there's no information. If you open the open message, do we have any information regarding the like any or like what I'm trying to say that password, you know what the password is not there. Only the TCP header the password information is present, right? See, so in the open message, this open packet, right? This open message is going to encapsulate the TCP. So in the TCP, we have a option two. Oh, sorry, MD5 flag. That is going to use the option 19 over there, right? And you can also verify, and this is the digest value, that's the password is quite used over there. So if you also verify from there as well as, so if you do one thing, show TCP brief, so show TCB, and copy this guy, and you can also get the information from there. Somewhere you see, what is that, man? Yep, you see, MD5, right? So you can also get the information from there. Uh, any questions, anyone? Now you can ask me. I'm done for the peer group. IBGP and EBGP dynamic membership. I have shown you, right? You can also limit that dynamic membership. You can use the BGP listen limit command. Okay, depending on the requirement, you can use the different subnets over there. You have a requirement, you can use the different subnets. Most probably what happened, you will see the dynamic navigation in the DMVPN sector, right? Not sector, we consider in a DMVPN technology. And the password, if you haven't used, this is only one option in the BGP, the password you can use the MD5, and the MD5 information will be exchanged in the TCP header. The flag number, not flag number, because the opcode will be 90. Okay. Any questions, anyone? Now you can ask me. No, so guys, I'm going to take a one more batch, not one more batch. I can say that I just one more class of the BGP attributes. So this class I'm going to take not tomorrow. I think so. There is a holiday in between.